Salam, peace be upon you. My name is Muhammad Layak Siddiqui, the father of holophase, orientation and chirality as intrinsic aspects of Phi Pattern identity. There is a moment in a child's life when two things that seemed identical suddenly stop being identical. A child looks at their hands. At first, the hands seem the same. Each has 5 fingers, each has a palm, each can grasp, point, wave, and hold. But then the child tries to put the left glove on the right hand, or the right glove on the left hand, and discovers something surprising. Sameness can fail in a very particular way. The glove is not wrong, the hand is not wrong, but the feet is wrong. What changed? Not size, not material, not general shape. What changed was orientation. The glove was made for one-handed form, not its mirror partner. The pattern cared about direction. Left and right were not decorative labels added afterward. They belonged to the structure itself. This small childhood discovery opens the door to one of the deepest questions in pattern science. When does direction matter so much that changing it changes identity? This is the question of part 21. Until now, our journey has taught us to be very careful about sameness. We learned that a pattern is not the same thing as a claim about it, or a certificate about that claim, or the artifacts that support it. We learned that identity lives in invariant structure under declared lawful transformations. We learned that patterns can persist through change, that some may exist even when they are not yet legible, and that null results are disciplined refusals, not proof that nothing is there. But now we meet a new challenge. Sometimes two patterns look almost the same, yet they are not the same. A clockwise spiral and a counterclockwise spiral. A left-handed helix and a right-handed helix. A process running forward and that same process reversed. A positive sign and a negative sign in a system where sign matters. A sequence and the same elements in reverse order. In each case, the crucial issue is not that one pattern has more pieces than the other, or that one is larger or brighter or more complicated. The issue is that reversal changes what the pattern is. And when reversal changes what the pattern is, orientation must be tracked as part of identity. That is the core claim of this chapter. Some patterns carry intrinsic direction. If reversal, mirroring, or sign change alters their invariant identity, then orientation is part of the pattern's lawful signature and must be explicitly tracked. This chapter teaches us how to think about that carefully. It does not say all patterns are directional. It does not say every mirror image is a new pattern. It does not say left-right, forward-backward, and sign flip always matter. What it says is more disciplined. When orientation is material, it must be declared. When chirality is real, it must be tracked. When reversal changes identity, science must stop pretending it does not. Let us begin slowly, with ordinary life. When direction matters. Not every pattern cares about direction. A smooth circle does not care much which way you turn it. A sphere, in many ordinary descriptions, does not seem to care whether you rotate it. A plain, unlabeled line segment may remain the same if you flip it end to end. Some patterns are highly indifferent to reversal, but many others are not. A screw thread may be right-handed or left-handed. A shell may coil one way or the other. A river eddy may turn clockwise or counterclockwise. A written word may cease to be itself when letter order is reversed. A melody may sound radically different when played backward. A human staircase may twist in one direction, not its mirror twin. These are not minor aesthetic variations. In many cases, they affect function, composition, interaction, and persistence. A left shoe does not become a right shoe just because we decide to ignore the difference. A spiral staircase designed for one wall geometry does not become its mirror twin by interpretation. A threaded bolt that turns one way does not magically fit the thread cut for the opposite direction. This gives us our first principle. Orientation matters whenever reversal changes lawful fit, lawful composition, or lawful identity. That phrase, lawful identity, is important. We are not asking whether two things feel different. We are asking whether, under the declared transformation class of the framework, reversing them preserves identity or destroys it. That is the scientific version of the childhood glove lesson. Orientation is not decoration. In everyday speech, people often treat orientation as a kind of optional extra. They describe an object's size, shape, and color first, and only later mention which way it faces or twists, as if direction were merely a surface detail. Part 21 refuses that laziness. For some patterns, orientation is not decoration, it is part of signature. A pattern signature is the set of features that must be tracked if we want to identify it truthfully. Earlier chapters already taught us that signature may include invariants, topology, domain restrictions, boundaries, persistence conditions, or equivalence rules. Now we add another possibility, orientation. If a pattern's identity changes under reversal, then orientation belongs to its signature. This means orientation can determine what the pattern is, what counts as lawful sameness, how it interacts with other patterns, whether it composes successfully, and whether it persists across transformation. So orientation is not something added after the real work of identity is done. It is sometimes part of the real work itself. The simplest examples: spiral, helix, arrow, sequence. The best way to understand this is to move through very simple patterns. The spiral. Draw a spiral curling inward. Now, draw its mirror partner. If one curls clockwise and the other counterclockwise, they are not identical under orientation-preserving transformations. They belong to different directional variants. The helix. Picture a spring or coil. One version twists rightward as it rises. Another twists leftward. This is handedness. If that handedness matters to use or structure, the two are not the same pattern. The arrow. An arrow has a head and a tail. Flip it and you reverse its direction. Its structure is not indifferent to orientation. Direction is part of what it is. The sequence. Take the letters S, T, O, P. Reverse them and you get P, O, T, S. Same letters, different order, different pattern. Here, orientation is sequential rather than spatial. Order matters. These simple examples teach a general lesson. Orientation is not only about left-right in physical space. It can also belong to ordering, sign, flow, and process direction. That is why this chapter is broader than geometry. It is about any lawful structure in which reversal changes identity. 4. Chirality, the mirror that does not preserve sameness. Now we come to the most famous special case, chirality. Chirality means that a pattern is not identical to its mirror image under the declared lawful transformation class. The easiest example is your hands. The left hand and the right hand are not random strangers. They correspond closely. Each is the mirror partner of the other. Yet, no ordinary turning in space makes a left hand become a right hand. Mirror reversal is required. They are matched, but not identical. That is chirality. A chiral pattern has a mirror counterpart that is genuinely different in identity, not merely differently placed. Globes are chiral. Many shells are chiral. Many molecules are chiral. Helices are often chiral. Some defects and flow structures are chiral. Many order procedures or symbolic patterns can have directional counterparts that play the same role structurally. The formal point is chirality is non-identity under mirror reversal within a declared transformation class. This last clause matters. Chirality is not a mystical essence floating inside a pattern. It is a lawful distinction relative to what transformations are allowed. If your declared equivalence class says mirror reversal counts as sameness, then mirror partners collapse into one equivalence family. If mirror reversal is excluded, chirality becomes identity-bearing. So chirality is not just looks different in a mirror. It is mirror reversal fails to preserve lawful sameness under declared rules. That is why this chapter depends on part 17, where identity and equivalence were formalized. Orientation sensitive, orientation insensitive, and scope-dependent patterns. One reason orientation claims get messy is that people often speak as if there were only two possibilities. Either direction always matters or direction never matters. Reality is subtler. Orientation insensitive patterns. These are patterns whose identity is preserved under the relevant reversals. A perfect circle, under many ordinary claims, is insensitive to flipping. Some magnitudes care only about size, not sign. Some shapes care only about connectivity, not handedness. Orientation-sensitive patterns. These are patterns whose identity changes under reversal, mirroring, sign inversion, or order reversal. A left shoe is not the same as a right shoe. A clockwise vortex may not be the same as a counterclockwise vortex. A sequence reversed may cease to be itself. Scope-dependent patterns. Some patterns are orientation-sensitive only in certain regimes. At core scale, two screws may look the same. At U scale, handedness becomes decisive. At one resolution, two helical structures may appear equivalent. At finer resolution, their handedness becomes essential. In one claim type, reversal may be ignored lawfully. In another, it becomes central. This is why orientation always needs a declared scope. The question is not, does orientation matter in the abstract? The right question is, does orientation matter for this claim, in this window, under this transformation class, at this scale? That is the disciplined version. Hidden orientation assumptions, how science gets distorted. Now we reach the danger this chapter is designed to block. Orientation is one of the easiest things to smuggle. If hidden orientation assumptions enter a claim, several distortions follow. False sameness. Two patterns that differ by a material reversal are treated as identical because the claim never declared that orientation mattered. Mirror partners collapse when they should not. False difference. The opposite error can also happen. A reversal that lawfully preserves identity is treated as a wholly different pattern because the framework silently overstates orientation sensitivity. False symmetry. A claim may say a pattern is invariant under reversal when that invariance was never actually tested. The symmetry is assumed, not earned. Hidden asymmetry. A representation may use a coordinate convention that privileges one direction, and the analyst may mistake that representational choice for a property of the pattern itself. Composition errors. Two patterns may appear equivalent until they try to interact. Suddenly, one fits and the other fails. The hidden orientation difference shows itself too late. These are all anti-smuggling issues. They show why orientation bookkeeping is not optional detail but identity protection. Representation orientation versus pattern orientation. This distinction is one of the most important in the chapter. A pattern may look left-handed or right-handed in a drawing only because of how the drawing was made. A coordinate system may make one direction positive and another negative. A page may be flipped. A plot may invert its axis. A camera may mirror an image. None of this automatically tells us that the pattern itself is orientation sensitive. So we must distinguish representation orientation, how the pattern is displayed, drawn, labeled, or encoded, from pattern orientation, an identity-bearing directional property of the pattern itself. If we confuse the two, we can invent asymmetry where none exists, or erase real asymmetry by calling it just coordinates. This distinction is central to public rigor. Orientation claims, like all serious pattern claims, must survive the right kind of lawful representation change. If the alleged handedness vanishes when coordinates are relabeled in a lawful way, the handedness belonged to the representation, not the pattern. This is why Part 21 needs explicit gates and firewalls. Everyday examples that teach the whole chapter. A good foundation should always return to ordinary life. Gloves. The left glove and right glove are mirror partners. Their difference is not cosmetic. It belongs to fit and function. Shoes. Left and right shoes are not identical merely because both are shoes. Orientation belongs to their design. Screws and bolts. A right-handed thread and a left-handed thread differ in lawful coupling. Orientation determines use. Spiral staircases. One twist may fit a space or body flow, while the mirror version does not. Written language. Order matters. Reverse a word or sentence, and identity can change radically. Human body. The body is not a perfectly symmetric template. Some structures are identity-bearingly oriented. These examples matter because they show that Part 21 is not introducing a bizarre scientific luxury. It is naming something people already know, then disciplining it. Examples across scales. To show the universality of the issue, let us walk across scales. Molecular scale. Many molecules have mirror forms. One may fit a biological receptor while the other does not. Chirality here is not poetic. It is chemically and biologically material. Biological scale. Shell coiling, organ asymmetry, twisting vines, developmental handedness, and bodily laterality all show that living systems often carry orientation-sensitive identity. Fluid scale. Vortices, eddies, and large-scale storms may rotate in opposite senses. Sometimes the difference is incidental. Sometimes it is central. Geological scale. Fault slips, folded structures, helical mineral forms, and sedimentary spirals may preserve orientation-sensitive signatures of formation. Symbolic scale. Sequences, procedures, algorithms, and narratives often depend on order. Reverse them and identity changes. Topological scale. Winding direction, not handedness, oriented surfaces, and defect circulation all show that direction belongs to abstract structure, not merely visible appearance. Across all these scales, the lesson stays the same. Some patterns are what they are only because they phase, twist, circulate, or order themselves in a particular way. 10. Orientation and identity claims. Part 17 taught us that identity claims require a declared lawful equivalence class. Part 21 now sharpens that rule. If orientation may be material, then any identity claim must declare whether orientation-preserving transformations alone are lawful, whether mirror reversal is included, whether sign inversion matters, whether order reversal matters, and whether chirality is identity-bearing at the present layer. Without this, same pattern becomes underdefined. Suppose someone says two spirals are the same. That statement is incomplete. Same under rotation, same under mirroring, same only if winding sense is preserved. Different answers create different claims. So the framework forces the question into the open. This is one of the deepest habits pattern science tries to build. Never argue vaguely about sameness when a declared transformation class can settle the matter publicly. Part 20 taught us that persistence means certified survival of identity through change. Orientation refines that. If orientation is identity-bearing, then a pattern may fail persistence under reversal, even if many other features remain constant. A right-handed helix becoming left-handed is not always a small variation. In an orientation-sensitive regime, it may cross an identity boundary. So persistence claims may need orientation clauses. The pattern persisted with handedness preserved. The pattern persisted up to mirror reversal. Or the pattern did not persist because reversal changed identity. Without this, persistence can be misstated. Orientation and composition. Many patterns reveal their directional identity most clearly when they try to combine with other patterns. A glove shows its handedness when meeting a hand. A bolt shows its handedness when meeting a thread. A molecule shows its chirality when meeting a receptor. A sentence shows its order sensitivity when entering grammar. A melody shows its directional structure when performed. This teaches something profound. A pattern may carry an orientation distinction quietly until interaction makes it visible. So, orientation is not just about static appearance, it is also about lawful fit. That is another reason hidden orientation assumptions are dangerous. A pattern that appears equivalent in isolation may behave differently in composition. If we ignore direction too early, we make later interaction claims unreliable. Sign-sensitive structures. Orientation is not only spatial. Sometimes sign itself belongs to identity. A positive and a negative balance are not the same pattern in finance. A positive and negative charge are not always equivalent in structured physical settings. An uphill and downhill gradient are not the same process in many systems. A plus and minus operation may not preserve lawful fit. In some cases, sign can be ignored lawfully. In others, it cannot. So the framework must say, is sign reversal allowed in the identity class, or does it generate a new pattern? That is again the same orientation question in a more abstract form. Forward and backward. Process patterns often care about order. A recipe run backward is not the same cooking procedure. A proof reversed is not usually the same proof. A story retold backward changes structure. A glass shattering and shards leaping back into a glass are not usually treated as the same process. This does not require metaphysical speculation. It only requires honesty. In many process claims, order belongs to the pattern. So orientation can be temporal or sequential. Forward and backward are not always interchangeable. This prepares the bridge to part 22, where reversal bookkeeping becomes systematic. The rigor layer. Part 21 installs several gates. Orientation gate. Is orientation material to the claim? Equivalence gate, which reversal operations are included or excluded from lawful sameness. Scope gate. Is the orientation sensitivity local, global, scale-dependent, or regime-dependent? Chirality gate. Has mirror non-equivalence actually been established within the declared class? A serious orientation-sensitive claim must declare the orientation convention, the allowed reversal class, whether chirality is identity-bearing, whether sign reversal matters, whether order reversal matters, and whether the sensitivity belongs to the pattern or only to the representation. Without these declarations, the claim is too loose for public science. 16. Firewalls. This chapter also installs explicit protections. It blocks hidden handedness assumptions, silent mirror identification, false asymmetry claims, mixing representation orientation with pattern orientation, and importing later physical reversal ideas without first grounding them at the pattern level. These are anti-smuggling firewalls. They keep direction from being hidden inside private intuition or accidental convention. What this chapter installs. By the end of part 21, the framework gains orientation-sensitive identity as a lawful possibility, chirality as a stable invariant distinction when appropriate, explicit reversal bookkeeping as part of claim structure, protection against hidden handedness assumptions, and a bridge to systematic reversal accounting in the next chapter. This means that identity claims can no longer silently assume that reversal is harmless. They must either earn that assumption or reject it openly. Refusal conditions. A claim should be refused if it asserts chirality without a declared transformation class, it assumes reversal sensitivity without testing or declaration, it hides orientation conventions, it treats chiral patterns as identical without justification, or it lets mirror and non-mirror claims depend on undeclared coordinates. These refusals are not bureaucratic. They protect the truth conditions of identity. The deepest lesson. The deepest lesson of part 21 is this: sameness is not always neutral. Some patterns are what they are only because they twist a certain way, point a certain way, order themselves a certain way, or carry a sign that cannot be erased without changing identity. In such cases, direction belongs to essence. So a mature pattern science must know how to keep books on direction. It must know when reversal preserves identity, when it breaks identity, and when the answer depends on scope. That is what this chapter installs. Closing image, the lock and the key. Imagine a key. Its mirror image may look almost identical. Same length, same metal, same number of teeth. But put the mirror key into the lock, and it does not turn. The difference is not decorative. The lock itself teaches you that chirality matters. Reality is often like that lock. It does not care whether we feel two patterns are basically the same. It responds to the structure that is actually there. Part 21 exists so public science can do the same. And once orientation becomes identity relevant, the next step is unavoidable. We now need a disciplined language for reversal itself. Sign reversal, spatial reversal, time or order reversal, and their combinations. That is the work of part 22. Because once direction matters, reversal must be tracked with the same rigor we have demanded of every other aspect of pattern identity. Always, peace be upon you.